Hello, this is Jeremy Wilkie. As you know, we've been hyping up our 4CS asymmetrical system here for quite a long time, and so I wanted to do kind of a three-part series. Here's the big one, and I've alluded to this before, and I've talked a little bit about our understanding of the 4CS and maybe how the whole system in general is really confused in the marketplace. And I guess this is really a good time to show you these details. So the first one's really going to be about the stock 4CS and really how it works. Not really into the details specifically as far as what we're doing. Okay, so here's how our position really evolved. It was the first time we took the fork apart and we observed this little check valve up here. At first it was like, okay, well, it's a handy way for that thing to refill if the pressure ever, if the cartridge ever dumps or anything like that. And as I kind of ground on that for a long time, it suddenly started to occur to me that the real tiny little mid-valve piston with the small holes, in conjunction with this huge base valve area for a tiny little spindle, and knowing that the WP engineers clearly had to, know what they were doing from a design intent, I couldn't get my head around it. It didn't really seem to make a whole lot of sense. Then suddenly it occurred to me. The 4CS is not a kind of hybrid twin chamber, small 8mm spindle, 20mm cartridge fork. It's actually a TTX design. And what's really cool about that, of course, is what it allows us to do from a tuning standpoint if we take the design further. Kind of, finishing the details that the WP engineers that designed it, I'm sure, wanted to do, but from a cost standpoint, couldn't. And then, now suddenly the design intent is becoming clear. So, here's what actually happens. Of course, this is all, riding inside of the fork tube, and of course it's sealed at the top. Of course, it's going to be, sealed via the base valve down here at the bottom. And so now we really have a twin tube design. And so what happens is, of course, is at very low speeds you get typical, fork movement, and the order of operations is going to be, of course, the bleed. And one of the things that we do in our modifications here is we actually plug this bleed off, and we do that to better allow our adjuster to work. But bottom line is basically we get displaced rod volume, no big deal, right? So it's bleed, and of course that volume is being displaced by this compensation cylinder here. And then the next order of event basically is going to be we're going to start seeing some bending, breaking open of the shims, etc. And then, of course, at some point, the mid-valve, having checked, is going to reach a flow threshold. And then at that point, basically, you're building pressure on the clicker. Okay, and then the stack opens up, and the fork, operates. Now, what happens if we get a sudden acceleration or a spike? Well, the really cool thing about this is the way the system's designed. If we get beyond a certain pressure here, this base valve with this huge area essentially is linear. So there's kind of a yield or an opening point, and then at that point, it really doesn't matter how much fluid we push through it, damping coefficient is going to be a pretty linear response. And then at that time, the mid-valve actually dumps the fluid. That's exactly how a TTX system works. So again, the 4CS is basically a different version of the Öhlins TTX design. Now, let's talk about one other thing. Of course, they've separated the rebound and the compression legs, and they do that through this bullet up here. And the bleed is, of course, common. The only thing that's different is, if you've ever taken one of these apart, is the direction of the needle in there. And, I'm not going to get into how that works. I think it's pretty clear. It's just, one way for compression, one way for the other. But one of the interesting things is, of course, this side here, being the red side, is the rebound. On the compression side, that bleed is actually bypassing the bottoming control mechanism. And on the earlier models where the bottoming control actually did something, you were really minimizing the effect of that due to that bypass. What's kind of interesting about these 15 model 4CS forks is that they're 100% relying on air spring for bottoming control. So I'm not even really sure, to be honest with you, why these parts are in here, because they're essentially doing nothing. As you can see, you've got these huge 4 bypass holes in the bottom of this hydraulic cylinder. That relegates it to completely useless. And one of the complaints that riders are going to talk about after riding this bike is how harsh and stiff it is in braking bumps. And that's kind of like the worst characteristics of an air fork, in that we have this huge pressure rise on the spring side of it due to the decreasing volume of the fork. And if you attempt to lower that oil height to make that mid-stroke smoother, you end up with an enormous bottoming problem, because there is essentially no secondary bottoming system. All right, well, those are the bullet points for right now. And again, this has been the video on the big concept, how the 4CS fork works, and why it's not an 8mm, 20mm twin chamber fork. Again, it's a TTX design. Might have to watch this video a couple times. I don't mind answering questions about it. So if you watch this video and it's not perfectly clear, again, feel free to email me. We're going to offer a couple more parts to this, and that's going to be what we're doing to address these with our 4CS asymmetrical system. Thank you.